Hello and welcome to Selection with Sathi. Today we will understand the difference between compilers and interpreters, two fundamental approaches to executing source code. We will also see how Python actually works under the hood, because Python is neither purely compiled nor purely interpreted. Let's start with compilers. A compiler takes your entire source code and translates it into machine code in one go. The result is a standalone executable file like a .x on Windows or a .out on Linux. Once compiled, the program runs directly on the CPU without needing the compiler again. Languages like C, C++, Go, and Rust all use ahead-of-time compilation. The advantage is fast execution. The trade-off is that you must compile before every run. Now let's look at interpreters. An interpreter reads your source code and executes it line by line or statement by statement. There is no separate machine code file generated. If line 5 has an error, the interpreter runs lines 1 through 4 successfully and then stops at line 5. Languages like Python, Ruby, JavaScript, and PHP are traditionally called interpreted languages. The advantage is easier debugging and faster development cycles. Let's compare compilers and interpreters side by side. Execution speed: compiled code runs faster because it's already machine code. Interpreted code has translation overhead at runtime. Debugging: interpreters are easier to debug because they stop at the exact line with the error. Compilers report all errors at once, which can be overwhelming for beginners. Portability: interpreted languages are more portable. If the interpreter runs on a platform, your code runs there too. Compiled binaries are platform-specific unless you recompile. Here's the interesting part: how Python actually works. When you run python hello.py, Python first compiles your source code to bytecode. This bytecode is saved as .pyc files in the __pykitch__ folder. Bytecode is not machine code, it's a low-level, platform-independent representation. Then the CPython virtual machine interprets this bytecode instruction by instruction. So Python uses a hybrid approach: compilation to bytecode, then interpretation by the VM. Python has multiple implementations, each handling execution differently. CPython is the default: it compiles to bytecode and interprets it on the CPython VM. PyPy uses a Jython compiler, just in time, which compiles frequently used bytecode into native machine code at runtime, making it 4 to 10 times faster than CPython. Jython runs Python on the Java virtual machine, letting you use Java libraries. IronPython runs on the .NET CLR. And MicroPython is a tiny implementation for microcontrollers.
Let's see C compilation in action. We write a simple Hello World program with printf. We compile it with gcc hello.c-o hello. This creates a binary executable file called hello. Now we run /hello, the binary executes directly, no compiler needed. You can copy this binary to another machine with the same OS and it will run without GCC. Now let's see how Python runs the same program. We write print hello in hello.py. We run python hello.py and the output appears immediately. Behind the scenes, Python compiled the source to bytecode and stored it in __pykh__. Next time you run the same file, Python reuses the cached bytecode if the source hasn't changed. There's no separate compile step. It all happens transparently in one command. We can actually see Python's bytecode using the dis module. Import dis, then define a simple function, definite add a comma b colon return a plus b called dis.dis of add, and Python shows you the bytecode instructions. You'll see load underscore fast a, load underscore fast b, binary underscore add, and return underscore value. These are the low-level instructions that the CPython VM actually executes. Understanding bytecode helps you optimize performance-critical code. Let's compare execution speed between compiled C and interpreted Python. We compute the sum of numbers from 1 to 10 crore in both languages. C with GCC optimization flag -O to finishes in about 0.08 seconds. Python using the built-in sum function takes about 3.5 seconds. That's roughly a 40x difference for this CPU-bound loop. This is exactly why libraries like NumPy use compiled C code under the hood for heavy computation.
Here are the key takeaways. Python uses a hybrid approach. It compiles source code to bytecode, then the VM interprets it. Use PyPy instead of CPython when you need faster execution. Jython gives 4 to 10x speedup. The .pyc files in __pykh__ are cached bytecode. Python recompiles only when the source changes. In interviews, always say Python compiles to bytecode first. Calling it purely interpreted is an oversimplification. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.